let's put the direct comparison test into action. As I mentioned in the notes, you notice that the p-series quite often is used when you're dealing with the direct comparison test. Not always, but quite often. We're actually use it a couple times in this situation as well. The first example that you see on your page and up here on the board is the series where the general term is 1 over n cubed plus 5. All right, and so that if n is 1, then we have 1 over 1 cubed plus 5, 1 over 2 cubed plus 5, 1 over 3 cubed plus 5, so on and so forth. All right, if we start to write in, we want to compare this series with one that either converges or diverges. Now, the instructions on the actual sheet say that you should show that this converges. Okay, so let's go ahead and do that. Let's pick the p-series that's similar to this, which is 1 over n cubed. We know that that series is going to converge because p is greater than 1. Right? What are the terms of that series? Well, if n is 1, we have 1. If n is 2, then we have 1 over 2 cubed, or 1/8. If n is 3, then we have 1 over 127, so on and so forth. So now let's compare the terms. All right, 1 is larger than a 6th, an 8th is larger than a 13th, a 27th is larger than a 32nd. All right, so the series that we're curious about is actually less than, the terms are less than the terms of the series that we already know converges. So 1 over n cubed plus 5 is less than 1 over n cubed. All right, and therefore, since 1 over n cubed converges, 1 over n cubed plus 5 must also converge. That's the idea behind the direct comparison test. A little more practice with it. Let's look at this one in green. The sum as n goes from 1 to infinity of 1 over n factorial squared. All right, n factorial, 5 factorial, we talked about this in an earlier video. 5 factorial is 5 times 4 times 3 times 2 times 1. All right, so 1 factorial is 1, 1 squared is 1, so we have 1 over 1. 2 factorial is 2 times 1, or 2. Squared is 4, so we have 1 over 4. 3 factorial is 3 times 2 times 1, or 6. 6 squared is 36, so on and so forth. Okay, let's compare this with another p-series that we know converges, 1 over n squared. Right? And again, I'm just doing squared because I'm keeping my exponents the same. All right, if n is 1, I have 1. If n is 2, I have a quarter. If n is 3, then I have a ninth. That's a 9. Whoops, there we go. If n is 4, then I have a 16th. All right. Now let's look at, keep going, the terms. So we compare them. Well, first time around the terms are the same. Second time around the terms are the same. But then 1/9 is larger than a 36th. And 1/16 is larger than 1/576. And that will be the situation going forward. So eventually, not necessarily right away, but eventually, the 1 over the quantity n factorial squared is less than 1 over n squared. Right? And then by the direct comparison test, since this series converges, this series must converge as well. It works with divergence too. So with divergence, we now have the series here in orange, 2 over n plus 1. Let's compare that with a p-series which we know diverges, 1 over n. Right? So if I have 1 over n, my first term is 1, my second term is a half, my third term is a third, my fourth term is a quarter, so on and so forth. Okay? If I compare, well, they're the same, right? And then 2/3 is greater than a half is greater than a third, 2/5 is greater than a quarter, and since this series diverges, and 2 over n plus 1 is greater than 1 over n, that means that the series I'm curious about must diverge as well. Right? So it works both ways in regards to the direct comparison test. Now, the direct comparison test, you can use that at all times, and it comes in handy on the exam when you're like, here's three quick series. Which of them, they use the Roman numerals, which of these, if any, converge, all right? And one of them might be a situation like this one right here, right? And you can look at that quickly and say, oh, well, I can use direct comparison test. I don't have to write it down because it's just a multiple choice question, but I can use the direct comparison test to prove that this series actually will converge, all right? The other situation where it may come up with is quite often on the exam, at least in recent years, they've been throwing the direct comparison test and its definition, what I had in the previous video, as far as saying, well, okay, here we want to know about A sub n. Well, we know that A sub n is less than B sub n. Which of the following is true? And then it'll say something like, well, if B sub n converges, then A sub n diverges. If B sub n converges, A sub n converges, so on and so forth, assuming that, whatever the inequality happens to be. So you want to be prepared not only to use the direct comparison test, but also to just have the verbiage of the theorem down so that when you see the symbology in the question, should it appear, you're ready to go.